Hello, my name is Dr. Dan Wedding, and this is DrWedding VB24, UDP/IP network sockets, with an Arduino example and a Picaxe 28x2 example. In this demonstration, I am using components and modules that I purchased on the internet. I purchased these with my own money. I was not compensated in any way from the manufacturers or their suppliers. These are just the parts that I used to make the network connections. This video will use local IPv4 network addresses, ports, switches, and the UDP/IP protocol to connect a VB program to an Arduino and then a Picaxe 28x2 microcontroller. Normally, I start and finish these videos with a PowerPoint presentation. For this video, the PowerPoint was removed and made into its own video. If you are familiar with the terms used in the overview and you have a basic understanding of networking, then you should be able to easily follow this video. However, if you are not familiar with these terms, you have no networking experience, or you just feel you need to brush up on your networking skills, please watch my previous video, DrWedding VB23, Networking Basics, for beginners with little or no networking experience. There are two transport layer protocols used to send data over the internet and local networks. They are UDP/IP and TCP/IP. This video only covers connecting a VB program to a network using UDP/IP. First, the program will connect to an Arduino Metro Mini microcontroller. Next, the program will connect to a Picaxe 28x2 microcontroller. If you are interested in TCP/IP communications, please jump to my next video, DrWedding VB25. For both microcontroller demonstrations, the PC's IPv4 address is 192.168.0.10. This is a fixed IP address. The subnet mask is 255.255.255.0. The computer will communicate with a USR-TCP232 module. This module will convert the UDP/IP network communications into serial communications and send it to the microcontroller. Because this module is taking care of all the networking, you can add any device with a serial port to your network. On the manufacturer's website, there's a free download that will allow you to easily configure the module to your needs. You can search for the software by name shown below. Make sure you are getting the code from the manufacturer's website. To configure your module, plug your computer and the module into a switch. Apply power to the module per the manufacturer's directions. Run the setup program. Press the Search in LAN button. The software will search the network and report all the modules it finds. The list will be displayed in the Device List in the Net window. To configure your module, select the module from the list, and the current settings are shown in the parameters. You can change the settings. In this example, I set the network communications to UDP/IP with a fixed IPv4 address of 192.168.0.7. The subnet mask is 255.255.255.0. The module will listen on port 57878. It will transmit to IP address 192.168.0.10 on port 51010. The serial side of the communications is set to 9600 baud, no parity, 8 data bits, and 1 stop bit. When you're finished, press the Set Selected Items via LAN button. Configure the second module the same as before. Select the module from the device list, set your parameters, set the selected items via LAN. The second module is configured the same way, with only one difference. The IP address of the module is 192.168.0.8. This is all the information. The best way to learn is through an example, so let's get started. I have opened up a new project, and the form for this project is on the left side of the screen. On the right side of the screen, you will see two protoboards along with the IP addresses associated with them. There are two sections on the form, a yellow section and an orange section. The yellow section will communicate with the board with the IP address of 192.168.0.7, and the orange section will communicate with the board that has the IP address of 192.168.0.8. Both sections have two buttons, one with red text and one with green text. When the button is pressed, the VB program will transmit the letter R or G to the IP address printed on the button. The board will receive the letter and toggle the red or green LED. On the board side, there are two buttons. When these buttons are pressed, the board will send B1 or B2 back to the Visual Basic program. The program will display the received data on the rich text box below the buttons. A rich text box was used instead of a text box to allow the program to change the colors of the text depending on which button was pressed. There's a text box at the bottom of the form to display any error messages. Finally, a timer has been included on the form. This allows the network traffic to be checked regularly. Now let's look at the code. But before I start, I want you to be aware of one possible pitfall. If your VB program can transmit data, but not receive data, it might be your firewall settings. At the top of the code, there are 5 global variables. The first 2 global variables are socket variables. They connect your VB program to a port. The first socket is for transmitting data and is attached to port 57878. The second socket is for receiving data, and it is attached to port 51010. The third global variable is an IP endpoint variable, and it is attached to the receiving port 51010. When data is received on this port, this variable will record the IP address of the sender. The last 2 global variables are byte arrays. The first one is used to store incoming data, and the second one is used to store the data that is going to be sent. Inside of form load, there are 2 tasks. First, the blocking property for both socket variables is set to false. This will prevent the program from freezing. When blocking is true, the program will wait for data to be transmitted or received. This will prevent the rest of the program from running. The second task is to set the timer interval for 100 milliseconds and turn on the timer. Inside the form closing subroutine, the socket variables are disconnected from the ports and the resources are freed up. The code for the 4 buttons is nearly identical. I started off by calling a subroutine called toggle color. This has nothing to do with network communications. I wrote this subroutine to toggle the background color of the buttons to make it easier for you to see when I am pushing the buttons. This can be ignored and removed if you wish. The next 3 lines are what really transmits the data on the network. The first line sets up the transmitting socket variable to transmit to 192.168.0.7 on port 57878. The second line puts the data into a format that can be used by the socket variable. In this button, the data being sent is capital letter R. The third line sends this data to the IP address. It's that simple. The code is repeated in the next button, except this time it's transmitting a capital letter G. The last two buttons are just a copy of the first two buttons. However, this time, the socket variable is transmitting to 192.168.0.8. The buttons were used to transmit data on the network. The timer is used to check if any data has been received from the network. This timer is executed every 100 milliseconds, and it checks if any data has been received. If no data has been received, nothing happens. If data has been received, the if statement is executed. The information that was received is copied into the byte array receive bytes. And the IP endpoint variable from IP stores the IP address of the sender. A nested if is used to compare the IP endpoint variable from IP to the IP address 192.168.0.7. If these two values match, the received data is copied to the first rich text box. If the IP endpoint variable from IP is equal to 192.168.0.8, the received data is copied to the second rich text box. As before, I am calling the subroutine toggle color. This is here to help you see that I am pushing different buttons. This subroutine can be ignored and removed if you wish. Finally, the entire receive code is put inside of the try of a try catch, and the catch will echo an error message to the error text box. The final subroutine is toggle color and is not necessary for communications. When a button is pressed or data is received, this subroutine is called and a value is passed to it. The value passed is used by the outer if statement to select the item being updated. The nested ifs are used to toggle the color. For example, if button microcontroller 7 red is pressed, this subroutine is called and passed a 1. The 1 causes the if to execute. Inside the if is a nested if that looks at the background color of the button. If the button has the original background color, it sets the background color to the highlighted color. If the background color is the highlighted color, it sets the background color to the original color. Now I will run the program and demonstrate that bidirectional communication has been established over the network between the Arduino boards and the VB program. I plugged the computer and both Arduino boards into a network switch so they are on the same network. I've also applied power to the boards. There are 4 buttons on the form. When I press the buttons on the form, it sends the data to the selected microcontroller and toggles the desired LED. Each of these Arduino microcontrollers has 2 buttons attached to it. When a button is pressed, the microcontroller will transmit B1 or B2 to the VB code. The code will identify which Arduino sent the information and which button was pressed. It will display the received data on the correct rich text box. A copy of the VB code, the schematic for the Arduino boards, a parts list for the Arduino boards, and the code embedded into the Arduinos are all in a single file that is available as a free download. A link to this download is in the description below. Now I will run the program and demonstrate that bidirectional communication has been established over the network between the Picaxe 28X2 boards and the VB program. I plugged the computer and both Picaxe boards into a network switch so they are on the same network. I have also applied power to the boards. There are 4 buttons on the form. When I press the buttons on the form, it will send data to the selected microcontroller and toggle the desired LED. Each of these Picaxe microcontrollers has two buttons attached to it. When a button is pressed, the microcontroller will transmit B1 or B2 to the VB code. The code will identify which Picaxe sent the information and which button was pressed. It will then display the received data on the correct rich text box. A copy of the VB code, the schematic for the Picaxe boards, a parts list for the schematic, and the code embedded in the Picaxe are all in a single file that is available as a free download. A link to this download is in the description below. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.